Do you know the longest mountain range on Earth is underneath the sea? Have you wondered how ocean basins were created and why they are where they are? All these questions can be answered by plate tectonics, especially processes associated with divergent plate boundaries. In this episode, we're going to introduce you to divergent plate boundaries. A divergent plate boundary is where two plates move away from each other. Here's a map showing Earth's topography without ocean water. You've probably already noticed these strange black lines. These show what we call a Midocean ridge, and they mark the divergent plate boundaries, which are almost entirely hidden under the water. The Midocean ridge system can be traced around the world like the seams of a baseball, and is the longest linear uplifted feature of the solid Earth. The Midocean ridge system is about 55,000 kilometers long. That's almost 8 times longer than the Andes Mountains of South America, which is the longest above-water mountain range in the world. From looking at a map, it's hard to see their height, but from the side view, we can clearly see that the Midocean ridge system is a chain of undersea mountains, with tops that are commonly 2 to 3 kilometers higher than the seafloor on either side of them. The steepness of mid-ocean ridges is controlled by how fast the plates are moving apart. Remember, we told you in an earlier episode that the plates move at different speeds? The fastest moves about as fast as your hair grows, and the slowest moves about as fast as your fingernails grow. When the spreading rate is low, the mid-ocean ridge tends to form a middle valley at the divergent plate boundary, which scientists call a rift valley. This is what we can see in the Atlantic Ocean. When the plates spread more rapidly, the divergent plate boundary makes a gentle undersea mountain rise without a valley, as we see in the eastern Pacific Ocean. We haven't known about mid-ocean ridges for very long. The first indications that an underwater ridge runs down the middle of the Atlantic Ocean basin came from the results of the British Challenger expedition in the 19th century. It wasn't until after World War II, when the ocean floor was surveyed in more detail, that the full extent of the mid-ocean ridges became known. Scientists then explored the other oceans and seas and discovered that mid-ocean ridges are not unique to the Atlantic Ocean. They also found that plenty of shallow earthquakes happen beneath the ridge crest. Scientists actually traced the mid-ocean ridges using these earthquakes. Moreover, fresh lavas were found in the Rift Valley, indicating recent volcanic eruptions. They found less sediment at the ridges than on the sea floor farther away, suggesting that the ridges were young. When researchers probed the crust to measure temperatures, they found that the crust was warmer at ridges than elsewhere in the ocean. All this evidence told scientists that something unusual is happening at mid-ocean ridges. Scientists now think what happens at mid-ocean ridges is they mark where two plates move away from each other at a divergent plate margin by a process called seafloor spreading. The space between the two plates allows hot, solid rock from the asthenosphere to rise up and partially melt to form magma. When the magma reaches the sea floor, it erupts as lava, cools rapidly, and forms an igneous rock called basalt. These basalts become the new sea floor. This is how the lithosphere and its plates grow at divergent plate boundaries. As you have probably already noticed, the movements of the plates toward convergent plate boundaries and away from divergent boundaries are connected. Seafloor spreading at divergent plate boundaries makes new oceanic crust and lithosphere at the same time that subduction at convergent plate boundaries destroys old oceanic crust and lithosphere. Scientists now think that plate motions, including moving apart or divergence at mid-ocean ridges, is caused by the sinking of oceanic lithosphere in subduction zones at convergent plate boundaries. Most seafloor spreading happens under the sea, but a related process happens in the continents, called rifting. Continental rifting splits one continent into two or more tectonic plates, and sometimes evolves into a divergent plate boundary and a mid-ocean ridge with seafloor spreading. This process can be observed in East Africa, where the East African Rift will eventually break Africa in two and create a new ocean basin millions of years from now. Another example is the Rio Grande Rift Valley of New Mexico. Continental rifting creates earthquakes, rift valleys, mountains, and volcanoes. Now we have discussed the two types of plate boundaries that tell us where oceanic plates are formed and where they are subducted. What do you think the third type of plate boundaries will be? You will find the answer in our next episode when we learn about transform plate boundaries. Thanks for watching. See you next time.